In this lesson, we're looking at graphing linear functions. So an equation in the form of y equals 2x plus 5 is a linear function, and its graph is a straight line. So a line has a gradient, which is the slope of a line, and a y-intercept, which is where the graph crosses the y-axis. So to calculate the gradient, we know, and we've seen in the past, that m equals rise over run. We can also say that it's the change in y over the change in x. Now, if we look at this example, we need to complete the table of values for the linear function of y equals 2x minus 3. Now, linear means it's a straight line, and that's what we need to remember. So what we're going to do here is, given our formula of y equals 2x minus 3, I have different values for x in the top of my table of values. And each time I'm working out or trying to find what the y value is to go into the bottom. So here is x. So I have 2 times x, which in this case is negative 1, and then I'm going to take another 3 away. So 2 times negative 1 is negative 2, and then we take away another 3, so it gives us negative 5. So this is the principle, and this is the way that we work these out. So each time you would say, well, 2 times 0 is 0, take away 3 is negative 3. 2 times 1 is 2, minus 3 is negative 1. The other thing you might be able to see here is from negative 5 to negative 3, I have moved 2, a positive 2. Negative 3 to negative 1, I've moved a positive 2. So if we think, well, what is the next term going to be? I'm going to add 2, which would be 1. And I'm going to add 2 again, which is going to be 3. Now this positive 2 is basically what this number is here. So that number in front of x is how we can help us complete this table of values a lot simpler. This is also what our gradient is. So that means our gradient is a slope of 2. So we've filled in our table of values, and we are going to now graph this function. So it means I'm going to use each of these sets of coordinates. So if x is negative 1, y is negative 5. When x is 0, y is negative 3. So that's the point where my line crosses my y-axis, which is this number. When x is 1, y is negative 1. When x is 2, y is 1. And when x is 3, y is 3. And you can see there from drawing that we have our straight line. So if I then get my ruler, I can then draw a straight line going through all of these points. Yours might look a little bit cleaner and clearer, being able to use that ruler a bit more. And we need to make sure then we label that line. So that line is y equals 2x minus 3. So that's part B, and then the last part says look at the table of values and what's the pattern that you notice. So we've already spoken about this, and that we saw that it was going up by 2's. So going up by 2's, and that's the pattern that we can see. So a linear function has the form of y equals mx plus c, and that's our standard formula, where m is the gradient and c is our y-intercept. We use c because we use y as our starting part to my function. So write down the gradient and y-intercept for the linear function of y equals 2x minus 3. So m, which is our gradient, is 2. And c, which is my y-intercept, is negative 3. And we could see that our line crossed our y-axis at negative 3. And the gradient, well, that's simply telling me for every one across, how many am I going up? So if we look at this second example, it says write the equation of a line that has a gradient of a gradient of 2 and a y-intercept of 1. So if I remember y equals mx plus c, m being my gradient, so this is my gradient, and c being my y-intercept, I just need to write the formula with these numbers. So y equals 2x minus 1. In this one here, I have y equals negative 1/3 x, and then you could put plus 0, you don't have to, but if we make this simpler, it would be y equals negative x over 3. Now this last little part here is just talking about our positive and negative gradients. So a line with a positive gradient slopes uphill and a negative gradient slopes downhill. So if you think, here's your graph, positive is going this way. This is a positive gradient, and our negative gradient goes down this way. So how to graph a linear function without a table of values. I did already speak about that just a little bit before, but what we're doing is we're finding that y-intercept and plotting it on the y-axis. We then use the gradient and that rise over run to plot the next point. We then use a ruler to join up our points, and remember we put arrows on the end and label our equations. So graph each of these linear functions after finding the gradient and y-intercept. So in this question, y equals 3x minus 1. My gradient is 3 and my y-intercept is negative 1. So this is my starting point. So I go to my y-intercept at negative 1. And then this means rise over run. So if it's a rise of 3, it's a run of 1. So any number just means that the run has to be 1. So from this starting point of my y-intercept, I'm going to rise 3, 1, 2, 3, and run 1 across. That will be my next point. And I'll go again, 1, 2, 3, 1 across. We always do 3 points because it's a little bit more accurate than just doing the 2. And then we will draw in our straight line, put our arrows on the end, and label our equation. Alright, our next one, M and C, so our gradient or our slope this time is negative 4, so we know our line is going to go backwards or downhill, and my y-intercept is 2. So I start at my y-intercept, so for every 4 down, so 1, 2, 3, 4, I'm running 1 across. 1, 2, 3, 4, I'm just off the graph, oh, here, 1, 2, 3, 4, and 1 back. Okay, so you can go off the grid slightly if necessary, but try and line up specifically then those 2 points, and then if you've got that third one off the graph as best as you can. And lastly, we label it. And our last one here, my gradient and my y-intercept. So my gradient here is 1 over 4. So that's our rise and our run. And our y-intercept, if there's nothing there, it simply means our y-intercept is at 0. So this is my y-intercept. This one here is a rise of 1 and a run of 4. So 1, 2, 3, 4. Now I'm going to go back this way so I don't run off the graph. So I'm just going to go opposite. So this one I went up, so I'm going to go down. 1, 2, 3, 4. So you can see it's a very shallow line, or not a steep line. And we can then draw our straight line through. Put our arrows on the end and label it. And that's how we then use that y-intercept and gradient in order to draw a straight line instead of having to draw up a table of values every time.